So our next speaker is Paul Anderson. And Paul, for those of you who don't know him, Paul has done many things in his career, but he has recently been the director of the Aquaculture Research Institute at the university, and is also overseeing the CNET EPSCoR grant that's based between the university and University of New England. So I think he's going to tell us a little bit about that.
Right. Thanks, Sebastian. Good morning. Welcome to the University of Maine, and congratulations to Stephen and Jeff for putting together this program. Welcome to our Canadian colleagues, and it's my pleasure to give you a brief overview of some of the programs that I'm involved with here in doing research and technology work related to aquaculture. You're going to hear today from several people from the University of Maine and a broad portfolio of science and technology where there's synergy between US and Canada. And this particular segment here on aquaculture, I just want to remind you that I won't be talking about our marine fisheries, our wild science, fisheries science, but there's a lot of that that's going on here, certainly with the University of Maine in partnership across border. And I'll just point out a couple of posters at that back table, and Dr. Gail Zalewski is here, where she's done some really neat work in partnership with Canada around ocean renewable energy kinds of projects and the relationship to the ecosystem. But I want to tell you briefly about a few programs that I'm involved with. I'm going to touch on Sea Grant, describe that for you. The Aquaculture Research Institute is also an institute that I direct here. It's a small group of scientists. And then that group is experiencing growth in our capacity, both at the University of Maine and with our partners through this project called CNET that you heard about just a moment ago. So I'll try to give you a brief update on those things. Am I doing this right? Yep. Sea Grant is a, come on back. Sea Grant is a federal-state partnership program that is all around the country. It's kind of a rip-off of the land grant concept. Here in the United States, President Lincoln signed the Land Grant Act during a war that was happening back in the 1860s and had nothing else to do, I guess. So he created what became our nation's university structures in the land grant system. As that emerged over time, it ended up with these three elements that our universities in the United States follow under the land grant, with research, education, and engagement all combined together. That tripartite mission seemed interesting as it was being applied to agriculture, mechanical engineering, and other kinds of needs here in the United States. And so about 50 years ago, a handful of senators got together and said, why don't we do that for the ocean? And therein became Sea Grant. So Sea Grant is funded through NOAA, the National Oceanic and Atmospheric Administration, and is a partnership with primarily land grant institutions around the country. There are 34 Sea Grant programs, and the University of Maine is one of them. And we do implement research through competitive research programs. We pass through dollars in a competitive peer-reviewed kind of research manner. We have our own efforts in K-12 education, as well as a lot of work with college students and a lot of graduate-based research. And so we put through a lot of our NOAA money into the communities, and we follow strategic planning that's based on the needs of our stakeholders, but of course that has to resonate with the needs of the nation through NOAA's national strategic planning. A lot of our work here in Maine focuses on aquaculture, and we've certainly been involved in the work over the last 20 or 30 years here in Maine of standing up things like mussel aquaculture and oyster aquaculture. We've been involved with funding a lot with fish disease, fish health kinds of work, and other kinds of things. Our portfolio goes beyond aquaculture, includes wild fisheries, includes ecosystem services, ecosystem and habitat quality, and some work with coastal community development as well. One of the hallmarks of our program, and really what makes Sea Grant special, I think, is our marine extension team. And this is a group of folks that live and work in the communities they serve. And these are our team. It's co-funded with the Cooperative Extension here on campus and some other resources. And these folks work with communities. They do a little bit of applied science in their own work. They work with researchers to try to connect them to stakeholders. They help to bring science into conversations that matter for people that are living and working and recreating on our coast. And a few of these folks, you may recognize some of them. A few of them are particularly strong in the aquaculture world, where we do work in both seaweed, sea vegetable development, shellfish aquaculture, and to some degree working with the finfish world. The next thing I wanted to describe for you is, this is slow. So again, the Sea Grant portfolio includes shellfish aquaculture, working on husbandry kinds of issues, engaging the industry, as I mentioned, and helping to give communities a better sense of how aquaculture can grow in a sustainable way here in Maine. Another one, as Barry described, and I'll touch on this a little bit as well when I talk about CNET, but this is Sarah Redmond, they're pictured to the right, working with one of our industry members down in the Portland area, Paul Dobbins, who runs Ocean Approved, which is a sizable kelp aquaculture, and they also harvest wild, but they're at the forefront of sea vegetable development here in Maine. And that's her doing some work with them, developing some of the technology that's needed to grow these things. And then just a few images of some of the potential out there for this sea vegetable sector that both Barry and Sebastian touched on. The Aquaculture Research Institute here at UMaine, I took over directing this a couple of years ago. It's a small group of faculty and scientists who were primarily focused on fish health kinds of work. And in fact, that's what I did my graduate work on, was the immune system of salmon and trout. And so for 20 or 30 years here at UMaine, we've had a strong portfolio on fish health work and have worked a lot with companies like Cook around their needs for biosecurity types of research and technology. We have a laboratory here on campus called the Aquaculture Research Center. It's small, it's somewhat modest. It used to be a chicken barn, but we've tried to make it as sophisticated as we can, and we have small-scale studies going on many different types of marine organisms. Under the ARI umbrella, working in partnership with a lot of other institutions here in Maine, we get out into communities and schools and festivals and talk about aquaculture, talk about marine science to youngsters. And the touch tank phenomenon is a very popular one with little people. Some of the work that we've done in support of the salmon industry, and Michael referred to some of this, really has to do with everything from husbandry and challenges going on with their egg production and productivity, as well as fish disease kinds of work, looking at alternative treatments, vaccines, therapeutics. One of the bigger problems that is faced in the salmon industry around the world is the sea lice problem. Ian Bricknell is one of our faculty here at UMaine, and he's a preeminent scientist in the world studying sea lice ecology and a lot of different kinds of strategies that we've been employing here to understand this critter, how it exists in the wild, how it interacts with cultured fish. And so just a few examples of that work. This is Dr. Heather Hamlin, who's part of the ARI group, who's working on, she's an endocrinologist actually, and working on some of the peculiarities of physiology and these species of fishes, and understanding the fecundity and the quality of eggs. That is an important, again, an important factor for the industry's productivity. And again, as I mentioned, vaccines and this kind of work here is it's very technologically driven, and some of these disease agents may not be problems here in Maine, but they're problems around the world. And so University of Maine has a presence in the world community doing this kind of research on fish diseases. And we also offer other kinds of services and have worked directly with Cook and other kinds of growers going in to help them troubleshoot some of their problems related to this fish health stuff. Now, the Aquaculture Research Institute, as I just mentioned, has been primarily based on fish diseases and the departments that are involved with that. But the university wants to expand and bring other disciplines into that work. And I just want to show you an image of one of our field facilities. This is an aerial shot of the Center for Collaborative Aquaculture Research, which is up in Franklin, Maine. It's in Hancock County. It used to be a commercial salmon hatchery. 1980s probably. And then the university purchased it and has turned it into quite a sophisticated aquaculture research center, looking at all kinds of land-based flow-through systems and a whole combination of species that are being tried here, integrated aquaculture where you try to culture different types of organisms together. And it's a pretty fascinating facility. If you have not had a chance to tour it, you probably should put it on your list. There's a lot of neat things going on there. Unfortunately, I don't have enough time here to describe in great detail. Now, as part of building the capacity for UMaine to expand its research, technology, and workforce for aquaculture in Maine, and recognizing what Sebastian said, that aquaculture is going to grow, we put together a proposal to the National Science Foundation a couple of years ago, and it ended up getting funded under the EPSCoR project. And the EPSCoR project is intended to help small states like Maine build science capacity. And so this is a 5-year project that we got funded in partnership with a whole bunch of institutions, including Barry's group at University of New England. They're one of the lead co-leads on the project. And what we ended up funding is called the Sustainable Ecological Aquaculture Network. And so CNET is intended to expand this research capacity in the aquaculture sector and to work on STEM workforce elements, science, technology, education, and math, and engineering and math, and to try to help answer some complex questions around if aquaculture is going to grow in Maine and in the world, what are some of the technological and research questions that need to be asked and answered. And we think there's an opportunity for Maine to really be a go-to place for answering some of those questions in this context, but also for the whole planet. And again, with partnerships like University of New England, Bigelow Laboratories, the Down East Institute, the Gulf of Maine Research Institute, Island Institute, there's a whole bunch of players in the aquaculture universe here in Maine that we're trying to bring together under the CNET umbrella. It's a $20 million investment over 5 years. We're into year 2. And essentially, I could spend all day telling you about the research. In fact, tomorrow I'm going to for a similar gathering. We're doing an all-day event on the CNET project. But these are the 3 primary research themes, and much of the examples you just heard from the panel fit into these bins, where theme 1 is looking at carrying capacity. How does different types of aquaculture fit into our ecosystem, and what are the limits and constraints? What are the interactions of the ecosystem with these different organisms? There's a lot of ways to ask those questions, and we're taking an interdisciplinary approach to doing that, from biophysical science to engineering, and we also have a lot of social science happening with this project. Our second theme, changing ecosystems. You can envision, aquaculture in a changing world. What's going on around us with changes in temperature, changes in ocean chemistry? How does that affect current and future husbandry techniques? Are there new species that could emerge with these changes? Are there disease organisms that are becoming a problem or could become a problem? A lot of the stuff that Barry just talked about this flux going on. And we're studying these things both in laboratories and in the ecosystem, primarily getting as close to shore as we can, as Michael talked about. And the third and final science theme of the CNET project is social and ecological innovations. So what innovations are there that we can explore through food science, through engineering, and other kinds of technology to add value to the aquaculture sector here? Is it just a food production? Maybe not. Is there, nutraceuticals, pharmaceuticals that are available out there? What are some of the other food chain opportunities or value chain opportunities for Maine and the manufacturing sector to support a growing aquaculture industry? So a lot of engineers in this world looking at things like anti-biofouling components that might be better for the environment, looking at different structural designs that could work better in a changing environment and more stressful situations. So those 3 technological themes are woven together by a regional construct that the project has, wherein we're going to try to study these things in 6 different sections of Maine's coast, different biogeographic sections and different demographic characteristics, as well as tying it all together with social science and through what we're calling human dimensions research. And it's complex. There's a lot of players in that room, and the whole grant has somewhere around 200 participants on it. And all of these institutions are written into the grant. It's kind of my NASCAR slide, but a lot of great folks in Maine, and bringing them together around this common set of goals is really exciting. We have 20 graduate students, some of them in the room with us here today, who all started last fall, many of them on a PhD track, and they'll be, our students for the next 3 to 4 years. So thanks for your time. That's kind of a skim of the things that I'm doing and the University of Maine is doing with aquaculture research.